In this video, we will learn about the clockwise and anti-clockwise moments. So let's say if a force produces clockwise rotation in an object, then the moment of that force is called clockwise moment. For example, here we can see in the given figure force F1. This is the force F1. It is acting at a point P1. It produces a clockwise moment about the rotational axis passing through the point O. So here clockwise rotation happens, so we will be calling it as clockwise moment. However, if a force produces anti-clockwise rotation in an object, then the moment of force is called anti-clockwise moment. Here we can see in the second figure the force F2, it is acting at a point P2. It produces an anti-clockwise moment about the rotation axis passing through O. So we will be calling it as anti-clockwise moment. Now again, here we can see in this seesaw that is shown here, the moment of force exerted by child A due to her weight W1 is clockwise, because the force will be in this direction and the motion will be clockwise like this, because it will be going upwards. Then here we can say the moment of force exerted by child B due to her weight W2, it will be anti-clockwise in this direction we can see. So as per commonly followed sign conventions, anti-clockwise moment is taken as positive, but clockwise moment is taken as negative. Now let's see some illustrations and applications of moment of forces. A handle is fixed on the door at the maximum possible distance from the hinges. Here, let's say if we are having a door and here we are having the hinges, so the handle is fixed at a maximum possible distance. At here we can say this increases the moment of force and the door can be opened or shut easily even by applying a small force on the handle, because we know that it depends on the distance also. Then we prefer to use a wrench. So here we can see this is a wrench with a long arm. So usually wrenches have a long arm so that the torque of applied force is more and the nut can be easily made loose or tight. Then similarly, the village floor grinder, that is known as atta chakki, it is provided with a handle near its rim. Here we can see this is the handle, so that the perpendicular distance between the point of application of force and the axis of rotation becomes maximum, and consequently it is easier to rotate the grinding stone. Then while cycling a bicycle, a person applies a force by the foot on the pedal and the force produces a torque, and it rotates the large toothed wheel connected to the pedals. The movement is transmitted through the chain to the axle of the rear wheel and the bicycle moves forward. So all of these are the example of moment of force. A carpenter uses a screwdriver, and that is having a long and a thick handle. So when he applies force near the free end of the screwdriver tangentially along its circumference, the moment of the force about the other end is large enough and he is able to tighten the screw easily. The concept is that the perpendicular distance must be maximum possible distance. Then we know in the steering wheel of an automobile, force is applied tangentially. Here we can see force is applied tangentially to the rim of the steering wheel of an automobile. So it ensures maximum distance between the point of application of force and the rotational axis. So as a result, large torque can be provided by applying less force and steering wheel can be turned easily. So this will be anti-clockwise moment and this will be clockwise moment. So from the above examples, we can say that turning effect of the force depends on the force, and second, the perpendicular distance of line of action of force from the axis of rotation. Greater the perpendicular distance we have seen, greater will be the turning moment of the force. So I hope it is clear to you. Thank you.